Okay, so this first unit, we're going to be doing a lot of graphing this year and analyzing graphs, different types. Okay, that's going to be a big chunk of the year, in addition to some other topics. And the names, the name that we gave to things that we graph is called a relation. And this actually goes way back to grade 10. A relation is just simply some rule that associates one set of information with another. Could be words, could be numbers, could be both. Usually it's numbers. But we did see when we first looked at these in grade 10 that it could be words. We'll focus on numbers. So like if here's the situation. I plug in the number 2 and out comes the number 4. I plug in the number 6, out comes the number 12. I plug in the number 20, out comes the number 40. What's the rule? What's happening to the one that I put in all the time? You're multiplying by 2. So that's the rule. So that's a relation between two sets of information. First numbers, and then the second corresponding numbers, you'll just multiply those first numbers by 2. We saw a whole bunch of different ways that we could show a relation. They could be ordered pairs. So going back to that rule of multiplying everything by 2 or doubling everything. So if I plugged in 1, I'd get 2. If I plugged in 2, I'd get 4. If I plugged in 3, I'd get 6. And there's just 3 examples. But obviously there's infinite examples because I could plug in any number I want, positive, negative, 0. Okay. So that was one way we showed it. Another way we showed it was using an equation. If both sets of information were numbers. So going back to this double, to find the output or the outcome, whatever I input x, I times it by 2. There's your equation. Words. Well, how would you describe this relation in words? Output is twice the input. Something that we did in grade 10, but we're not really going to focus on this year, was we used these arrow diagrams where we put all the elements from the first set of information into a first oval, all the outputs into a second oval, and then connected them. So if it was 1 and I double it, it becomes 2. If it was 2, it becomes 4. Just showing that a different way. Table of values. First column are the inputs, second column are the outputs. And I can just list them. If I plug in 1, out will come 2 if I double it. If I plug in 2, out will come 4. And if we have a table of values or an equation, the last way is we can take one of those and graph it. So if we graph this one, it would look something like that. Those were all the different ways we could show a relation. And of course, much of what occurs in society is a relationship between two things, whether they're numbers or words or whatever, or people or objects. But then we talked about a specific type of relation called a function. Remember, anybody? What makes a relation a function? It's probably hard to remember. But a function is a relation where the input, that's one thing, that's one way you could call it, the input values or x values or domain values, those three all mean the same thing. They all represent information from the first set. The inputs, the x's, the domain. Never repeat. Domain never repeats. Okay? So like this here would be a relation, and it would be a function because the x values 1 and 2, they don't happen twice or 3 times. If I had a third pair here called 1, 1, it would no longer be a function. That's really just the difference you tell. So how do we tell if something's a function? Well, we just look at the x values and see if any of them repeat. But how can you tell from a graph? Sometimes it's a little hard to tell from a graph. If you can't, okay, so if you can't draw a vertical line through more than one point, it is or it's not a function? It is. If you can't draw a vertical line through more than one point, okay, it is a function. So for example, okay, let's just look at these two before I talk about this. Well, like here, what's the x value of this point here? That's the y value. 0. What about here? What about here? Okay, now every one of these x values has a corresponding y value. There's no point on the graph where the x value, where there's a point with the same x value, 2 points with the same x value. But on this graph, if I look at 2, x value 2, well, here's a point with an x value 2, but here's another point with an x value 2. Okay, so that means the x value 2 repeated. There was one answer here and one answer here. Same with 1. There was one answer here, one answer here. Same with 0. One answer here and one answer here. A whole bunch of them repeats. Okay, so this one would be not a function. But this one would be a function. And yes, you can tell. So a way to tell if an x value repeats is if you draw a vertical line and you hit more than one point. So if I drew a vertical line here, I hit this point and this point. That means that whatever this x value is, it happens twice. This x value and this point, this x value and this point. So if you can draw a vertical line through more than one point, it's not a function. If you can draw a vertical line through more than one point, It is not a function. And then we use special notation if it was a function. Instead of y, do you remember what we used? If it was a function, instead of the letter y in an equation, we used f of x. Okay, we use that fancy notation. It means the same thing as y, except if it's in this form, that just means it's a function as well as a relation. But they mean the same thing. Okay, so good idea to know what a function is and what is a function and what is not a function. That's really what I want you to get out of this first page. Okay. What else did we deal with when we talked about functions? Domain and range. Surely you must remember this. The domain values, all the x values. The range, all the y values. Okay? All the x values in a relation function. I keep meaning to take out these second lines because I don't know why I put 2 lines in for both. If it is a function. All the y values. In a relation / function. So we should be able to identify all the domain values in any function as well as all the range values in any function. So you don't have to flip back, I'll flip back. What's the domain of this function? Don't overthink. Domain are all the x values. That's it. What's the range? Yeah, that's it. This one, what's the range? Range, 2, 4, 6. What's the domain? Yeah. But what about graphs? Especially lines and curves. We had to use some fancy notation. Do we remember how to do it? Do you remember the name of it? There were 2 types that we learned in grade 10, but we kind of stuck to one of them. Interval notation. Okay, that's where we use brackets or parentheses, sometimes infinity symbols, depending on the question. Okay. Otherwise, numbers. So how do we find the domain of a graph, like a line or a shape or a curve? We always find the furthest x value to the left. What's the furthest x value to the left in this graph? -2. Comma, the highest. Because it goes up forever and to the right forever, it goes to infinity. Do we remember the symbols to put around them? Bracket around that because we include it. Always a parenthesis around infinity or negative infinity symbols. How about the range? Any idea? Sorry? -3 to infinity. Range, we're looking at lowest to highest. So now we're looking at the y value. So I go to the lowest part of the graph. What's the y value here? It's -3. That's where I start. What's the highest y value? This arrowhead tells me it goes up forever to infinity. Is this a function, yes or no? Yes, it is. Okay. How about this one? Domain 1 to 5, and we put brackets around both of them because we include both 1 and 5. How do we get that? Well, the x value of the point to the furthest left is 1. Furthest right is 5, and this tells us everything in between. If it's connected, that means everything in between. And that's how we show everything from 1 to 5. Range would be lowest to highest. -2 to +2 with brackets. Function, yes or no? No. Okay. This last one. What would it look like if you graphed it? What kind of shape would it be? Y equals 2. Okay, let me ask you this. What if it had an x squared in it? You'd probably be able to tell me the shape. A parabola, right? Because we talked about that last year in grade 11. What if it has no exponent, just x? Don't overthink. It's the simplest one. A line, right? And doesn't a line go on forever in every direction? So any line, the domain is always going to be everything, -infinity to +infinity. And so is the range, because it goes to the left forever, to the right forever, down forever, and up forever. Okay, the last thing I want to talk about is a review. Is something that we did a lot of in grade 10. We did a little bit of it last year. Was how to use function notation with equations. Remember, when you see these things, it just means it's a function. You can just replace them with y if you want to. Oh, okay, so what does this mean? I've got the function x plus 2, with which, if you graphed it, it'd be a line. And I'm asked to find f of 3. So I've replaced the x with 3. Instead of f of x, it's f of 3. So every time I see an x, I replace it with 3. So instead of x, I write 3 plus 2. And what does that simplify to? 5. So what that means is if in this function, if you plug in 3, out comes 5 because you add 2. What if we were asked to plug in 0 into function f? Well, every time you see an x, replace it with 0. And that works out to 2. This next one, you're asked to plug 2 in for x into every time you see an x in function g. So g of 2, every time I see an x, I'm going to replace it with 2. So I get 4 times 2 plus 1 over, instead of x, I put 2. And then I just simplify it. 4 times 2 is 8, plus 1 is 9. 9 divided by 2, you can't divide it cleanly, so just leave it as a fraction. You don't have to go any further than that. For g of 0, every time you see an x, replace it with 0. Can somebody tell me what this would work out to? Sorry? Undefined, because you can't divide by 0. So it doesn't matter what's up top here as soon as you divide by 0. It's undefined. Try the next one. You should be able to do the next one. Now we're taking -5 and we're plugging it into function h. So h of -5, which means every time you see an x, replace it with -5. And the one thing you got to be careful of in this question is squaring the negative. Remember, this is not 5 squared and then put a negative in front. This is -5 times -5, which is positive 25. And that will give you 75 minus 3, so your final answer will work out to 72. Remember, when you square a negative, it becomes positive. Sometimes we don't have to plug in a number at all. We could just plug in another expression. So don't let this throw you. All this means is, instead of every time you see an X, put an A. Well, I can't simplify that anymore. I can't add them together because I don't know what A is. So I'm done. It's over. Here, every time I see an X, I plug in an X minus 1. So 3, and then I put M plus 1 in parentheses, squared, minus 3. Well, I can do some work to this one. Because, remember, M plus 1 all squared means M plus 1 times M plus 1, which means 4 multiplications. So this is going to work out to 3. M times M is M squared. M times 1 is plus M. 1 times M is another plus M. 1 times 1 is plus 1. I keep those in parentheses because I got to keep that answer together because I'm still multiplying it by 3. And then at the end, I'm subtracting 3. So now I got to multiply everything inside by 3. So I get 3M squared plus 3M plus 3M plus 3. And then outside the parentheses was a minus 3. Well, the plus 3 and minus 3 cancel each other out. I can combine the two M's into 6M. And that's as simple as I can go. I can't put those two together. Okay? So that's using function notation. In grade 10, we were doing a lot of questions like A to E. Okay? But it doesn't necessarily have to be in an equation form to do function notation. So this is something that is a little new to you. What happens if the functions are shown in a different way? Like what happens if we're given an ordered pair, a set of ordered pairs for the function, or we're told the function in words, or, well, here is like an equation. Here we're given the graph. Here we're given a table. Don't overthink this. You are asked to find f of 0, so you need to go to function f. When x is 0 in function f, what's y? 3. It's whatever the 0 is with in the ordered pair. Here, x is 0, which means y is 3, or f of x is 3. So it's just 3. So to evaluate a function as a set of ordered pairs, just go find the ordered pair that has this x and then write the corresponding y. What about f of negative 8? How do we say it? Because I think we're all thinking the same thing. Is there an x negative 8? No, there isn't one. So this doesn't exist. It's not there. P of 5. Now you got to go to the function P of x, which is this one. Remember, it's when x is 5, not y. So when x is 5 in function P, what's y? Negative 4. When x is 5, y is negative 4. Okay? G of negative 1. Well, here's function g. It's a graph. So we got to find the points on the graph where x is negative 1. Well, here's negative 1. If I go up here, this is the point on the graph where x is negative 1. What's y? 3. So therefore, g of negative 1, the negative 1 is paired with 3. M of negative 100. Well, here's function m. Any ideas? Is there an x to plug in? No. What's the answer all the time? 4. So really, it doesn't matter what this number is. The answer is always going to be 4. Because there's no x to plug in. There's no calculation to be done. So it's just going to be 4. F, h is negative 15. So we got to go to function h. That's the one that tells us in words. A description, the function is described in words. So if x is negative 15, what's y? According to those words, negative 30. Because it's whatever you plug in, the output, whatever comes out, the y, is going to be twice what you plug in. And finally, and this one is worded a little bit differently. Notice you're not told what x is. You're told what g of x is. So really, this, remember, we can replace it with y. So this, we're working the other way around. You're given the y, you're asked to find the x. So now you got to go find the y value where it's 2, and then work backwards to find the corresponding x value. So it's the graph here. Well, what point is y equal to 2? Right there. That's the point. Well, what's the x that goes with that? 0. Therefore, if y is 2 in function g of x, x is going to be 0. However, is there another answer where y is 2? Is there another point on this graph where y is 2? Right here. That's the point 4, comma 2. So there's actually 2 points where the y value is 2. One where x is 0 and one where x is 4. That's why you were asked to find all values of x. Any questions? Okay. So that just is sort of a quick wrap up of what functions are. Now we're going to the rest of this unit, we're going to talk about different things that we can do to functions. Some of which you saw last year. We can move functions around. We can stretch them. We can flip them. We saw some of that last year with the stretching and the flipping and the shifting. Okay? So we're going to talk more about that in this unit. That's going to be sort of the focus of this unit. Okay.